Now see next question number 7 from exercise 1.2. Differentiate the following functions with respect to x. First sub question, cot inverse of cot of e raised to the power x square. So this question based on properties of inverse trigonometric function. We know the property cot inverse of cot theta is equals to theta. That means we have to simplify this inverse trigonometric function with the help of this property. Then we differentiate the function. That means we have to simplify the given function first. So we write in solution, let y is equals to cot inverse of cot of e raised to the power x square. So by using this property, instead of theta, value is e raised to the power x square. So we write this as e raised to the power x square. Now after simplifying, we differentiate it with respect to x. So write differentiate with respect to x. Derivative of y with respect to x is dy by dx. We know that derivative of e raised to the power x is e raised to the power x. So here instead of x, power is x square. So we also find derivative of x square. So we write into d by dx of x square. So e raised to the power x square as it is into d by dx of x square is twice x. So we write as twice x into e raised to the power x square. So if given function can simplify the given function, then find the derivative of simplified function. Now see second sub question, cosec inverse of 1 upon cos 5 raised to the power x. Here outer function is cosec inverse of, so we write here cosec inverse of cosec theta is equals to theta. That means we have to reduce this bracket in the form of cosec. So we write given solution as, let y is equals to cosec inverse of 1 upon cos 5 raised to the power x. So 1 upon cos theta can be written as sec theta. That means we use here 1 upon cos theta is equals to sec theta formula. So we write here cosec inverse of 1 upon cos, we write cosec, we write here 1 upon cos as a sec. So sec 5 raised to the power x using this formula. Now we have to reduce this sec in terms of cosec. So again we know the formula cosec pi by 2 minus theta, that is cosec 90 minus theta is equals to sec theta. So we write this as sec theta. Here instead of theta we have value 5 raised to the power x. So we write in bracket cosec inverse of cosec of pi by 2 minus 5 raised to the power x. So by this property cosec inverse of cosec theta equals to theta, we write this as pi by 2 minus 5 raised to the power x, which is value of y. Now here we simplify the given function. So we differentiate with respect to x to this function. So write derivative of y as dy by dx, derivative of first term minus derivative of second term, derivative of first term, that is derivative of pi by 2 minus derivative of second term, that is derivative of 5 raised to the power x. Now pi by 2, that means 90, which is constant, so its derivative is 0, minus 5 raised to the power x, that means we have to use here d by dx of a raised to the power x, that is a raised to the power x into log a. Here instead of a, value is 5, so we write here 5 raised to the power x into log 5. So we get a derivative dy by dx is equals to minus 5 raised to the power x into log 5. Now see third sub question, cos inverse of in root 1 plus cos x by 2. Here outer function is cos inverse, that means we reduce this bracket in terms of cos. So in numerator 1 plus cos x, that means we have to apply here half angle formula. 1 plus cos x is equals to 2 cos square x by 2. So we write in solution, let y is equals to cos inverse of in root 1 plus cos x upon 2. So we replace this 1 plus cos x by using half angle formula as 2 cos square x by 2. So we write here cos inverse of in root 1 plus cos square x by 2. So this 1 plus cos x we replace by cos square x, 2 cos square x by 2 upon these 2 as it is. So this 2 get cancelled in next step. So we write here cos inverse of root of cos square x by 2. So here square and square root get cancelled. So we write here cos inverse of cos x by 2. Again we know the property cos inverse of cos theta is equals to theta. So here in place of theta we have value x by 2. So we write this as x by 2. So we get here y is equals to x by 2. So differentiate with respect to x. So for our convenience we write this x by 2 as 1 by 2 into x. So derivative of y with respect to x is dy by dx. 1 by 2 is constant but with function x, algebraic function x. So we write derivative of x with respect to x as 1. So we get dy by dx is equals to half. Now see sub question 4. Cos inverse of in root 1 minus cos x cos of x square upon 2. So don't confuse with 1 minus cos x square and 1 minus cos square x. So these two are not same. Here square of cos x is given, here square of x is given. So we have to apply here formula 1 minus cos theta is equals to 2 sin square theta by 2. In our example value of theta is x square. So we write here 1 minus cos of x square as 2 sin square x square by 2. So first we denote the given function as y. So we write in solution let y is equals to cos inverse of in root 1 minus cos of x square upon 2. Now we have to reduce this bracket in terms of cos because outer function is cos inverse. So inner function if in cos form, so we write the property or we use the property cos inverse of cos theta is equals to theta. That means we try to reduce this bracket in terms of cos theta. So we write here cos inverse of. So first we apply 1 minus cos of x square, that is formula 1 minus cos theta equals to 2 sin square theta by 2. So we replace this 1 minus cos of x square by 2 sin square x square by 2 upon 2 as it is. So in next step these two will get cancelled. So we write here cos inverse of, when we write square root of sin square, so square and square root get cancelled, we get here sin of x square by 2. Now outer function is cos inverse, inner function is sin. So again by using the formula cos of pi by 2 minus theta is equals to sin theta. So we write this as cos inverse of cos pi by 2 minus x square by 2. So here cos inverse and cos get cancelled. We get value of y equals to pi by 2 minus x square by 2. By using this property cos inverse of cos theta equals to theta. So here in place of theta value is pi by 2 minus x square by 2. So we differentiate this function with respect to x. So right here differentiate with respect to x. Now here derivative of y is dy by dx, derivative of first term minus derivative of second term. So pi by 2 is single constant, so its derivative is 0. So first we write this as pi by 2 minus 1 by 2 into x square. That means derivative of first term minus derivative of second term. So while finding the derivative of second term, 1 by 2 is constant. So we write 1 by 2 as it is, because this with function x square. So derivative of x square is twice x. So in next step these two get cancelled. We write derivative of given function as minus x. Now see next example. Tan inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. So we have to apply here one formula. Tan alpha minus beta is equals to tan alpha minus tan beta upon 1 plus tan alpha into tan beta. So with the help of this formula we simplify this bracket so as to reduce this bracket in terms of tan. So we write given function as y. So write in solution, let y is equals to tan inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. Now we have to use this concept. That means we have to convert this one in terms of tan, and we know the value tan pi by 4. That means tan 45 is 1. So we use in place of 1 tan pi by 4. So write tan inverse of tan pi by 4 minus tan x by 2 upon. Here we required 1, so keep this 1 as it is. Now here we required tan alpha. Now we consider this 1 as tan alpha, that is tan pi by 4 in our example. So here coefficient of tan is not given. That means coefficient of tan is 1. So we write here coefficient of tan as 1. So in place of 1 we write tan pi by 4. So keep this 1 as it is. 1 plus tan pi by 4 into tan x by 2. Now this convert in the form of tan alpha minus beta equals to tan alpha minus tan beta upon 1 plus tan alpha into beta. So here in place of tan alpha we have tan pi by 4. In place of beta we have tan x by 2. That means this bracket can be written as tan inverse of tan of pi by 4 minus x by 2. If you apply this formula, you get value this. So here we come to the property tan inverse of tan theta is equals to theta. So here we write y is equals to tan inverse tan get cancelled. We get value pi by 4 minus x by 2. So we differentiate this. Differentiate with respect to x. Now derivative of y with respect to x is dy by dx. Pi by 4 is single constant, so its derivative is 0. This x by 2, so we write first pi by 4 minus 1 by 2 into x. So 1 by 2 is constant, derivative of x we have to find. So write 1 by 2 as it is, derivative of x is 1. So we get dy by dx is equals to minus 1 by 2. That means here we have to simplify this bracket first using this formula, and then we have to apply tan inverse of tan theta equals to theta property. Then after simplifying we differentiate the given function. Now see sub question 6. Cosec inverse of 1 upon 4 cos cube 2x minus 3 cos 2x. If you observe the denominator, this is triple angle formula. We know the triple angle formula. Cos 3 theta is equals to 4 cos cube theta minus 3 cos theta. Here in place of theta we have the value 2x. That means we have to apply this triple angle formula for this denominator. Then we get value in terms of cos. So 1 upon cos we again reduce to sec. Then that sec we have to reduce in terms of cosec. So first we write the given function as, so write in solution, let y is equals to cosec inverse of 1 upon 4 cos cube 2x minus 3 cos 2x. So in denominator we apply triple angle formula. So in place of theta we have 2x. So replace this theta by 2x in each term. So here we have to replace this theta by 2x. So we get here 3 into 2x, that is cos 6x is equal to 4 cos cube 2x minus 3 cos 2x. So we write this denominator as cos 6x. So write here cosec inverse of 1 upon cos 6x. So this 1 upon cos we write in terms of sec. We know that 1 upon cos theta is equal to sec theta. So we write this 1 upon cos. So write cosec inverse of this 1 upon cos 6x. We write sec 6x. Now we have to reduce this sec in terms of cosec. So we use the concept cosec of pi by 2 minus theta is equal to cos theta. So sorry, sec theta. So here in place of theta we have 6x. So we write here cosec inverse of pi by 2 minus 6x. So we use here square bracket. Now cosec inverse and cosec get cancelled. So we write as pi by 2 minus 6x. Now we differentiate with respect to x. Now derivative of y with respect to x is dy by dx. This pi by 2 is single constant, so its derivative is 0. 6 is constant, but with algebraic function x, so keep 6 as it is. Derivative of x with respect to x is 1. So we get answer as minus 6. Now see sub question 7. Tan inverse of 1 plus cos x by 3 upon sin x by 3. If you observe the numerator, this numerator is of the form 1 plus cos theta. So we have to write here formula 1 plus cos theta is equals to 2 cos square theta by 2. So if you reduce this numerator, then we have to reduce this denominator also. And for sin theta, we know the formula sin 2 theta is equal to 2 sin theta into cos theta. So here in place of theta we have x by 3. So first we write the given solution as, so given function as, let y is equal to tan inverse of 1 plus cos x by 3 upon sin x by 3. That means we have to simplify this bracket so as to reduce in the form of tan, because outer function is tan inverse. So we write this numerator as in bracket tan inverse of this 2 cos square. Now using this formula, instead of theta we have x by 3. So we write this as x by 3 and these 2. So we get x by 6. So we write here 2 cos square x by 6. If you not write directly, then substitute the value 1 plus cos in place of x. You have to substitute x by 3 is equal to 2 into cos square. In place of theta, you have to write x by 3 and this upon 2, that means 1 by 2. So we write this as x into 1 x, 3 into 2 6. So we write here directly x by 6 upon, here we have to write sin x by 3. That means in place of theta we have to write here, we required here x by 3. So we first find the half angle formula from this. So we write sin theta is equal to 2 sin theta by 2 into cos theta by 2. So you can directly replace here theta by x by 3. So we write here in place of theta x by 3. So 2 into sin x by 3 into 1 by 2 into cos x by 3 into 1 by 2, that is equal to 2 sin x by 6 into cos x by 6. So write this denominator as 2 sin x by 6 into cos x by 6. So 1 cos x by 6 get cancelled with 1 cos x by 6 from square. So we cancel this. 2 get cancelled. We get here value tan inverse of cos upon sin. We can write cot. So we write here cot x by 6. Now outer function is tan inverse. Inner function we require in terms of tan. So again we use the formula. Here bracket we write tan pi by 2 minus x by 6. We use the formula tan pi by 2 minus theta is equal to cot theta. So here in place of theta we have x by 6. Now this tan inverse tan get cancelled. So we write here y is equal to pi by 2 minus x by 6. We write 1 by 6 into x. So differentiate this function with respect to x. Differentiate with respect to x. So derivative of y with respect to x is dy by dx. Pi by 2 derivative of first term, that is constant. So its derivative rate 0. 1 by 6 is constant, but with algebraic function x. So we keep 1 by 6 as it is. Derivative of x with respect to x is 1. So we get answer as minus 1 by 6. So remaining questions you try with the help of these examples, and if you have any difficulty with property, you can watch video from trigonometric function. From part first you will clear all the ideas about this property, how to simplify the inverse function.